Hi, Ben. It's great to have you on the show.
Hi, Jeff. Nice to see you again. It's my pleasure.
Yeah, you're the second guest who went to the same college as I did in China, so it's very exciting. You are a pioneer in artificial intelligence and led a generative AI for coding at Google starting in 2018, an initiative that originally began as a moonshot at Google X. In this role, you were responsible for creating breakthrough technologies for moonshots across a wide range of verticals, including energy, agriculture, biotech, and robotics. Before that, you served as a distinguished engineer at major enterprise corporations such as eBay and Google. Recently, you founded a DeepMorph AI, a stealth startup dedicated to keeping humans in command and out of the bottleneck as AI transitions to writing the vast majority of software code. So let's dive right in. You are one of the first people to do AI coding in the world back in 2018. What triggered it?
All this kind of interesting example of a typical innovation comes for the Howard conversations over there. This really happens when I have a chat on the hallway with Astro Teller, who is CEO of the Google X, Spencer Schlinger, who is the CTO of X, and our founder, famous Sergey over there, was saying, hey, so AI is coming. What we can do? Maybe we should like replace our job. Just use AI to write a code. That's where it started. Eventually, start from this kind of conversation, lead into the Google-wide initiative.
Okay, well that's okay. Classic hallway conversation. Okay, so that's 8 years ago, right? Like who
Yeah.
else were the early pioneers like you guys?
Actually, so at that time, there's a lot of researchers, right, from academic side trying to say, hey, can we use deep learning, machine learning for software engineering? That's quite a lot of like research there. But working on the building a company to do this, or even building a large scale company-wide project, that's not a lot of people at all. I think the OpenAI pretty much start almost at the same time working on this stage that I know. Also, there's small ones like code completion pioneers like Tab9, those type of things over there. But those are kind of not using generative AI. We are very few, I think. I mean, probably there's a lot of more people I don't know. For
Mhm.
disclaimer,
Yeah,
as far as
yeah,
I know, we are very, very few, only few people working on that at that time. But nowadays, it's no brainer.
right, right. So can you name some of the popular products that people have been using that were built using AI coding?
So as far as today, it's harder to say which product is not using the AI to code it anymore, right? But just more or less. For the classic traditional enterprise, there are not a lot of percentage yet. It's coming up. But for a little bit modern IT companies like Google, for example, will have almost 70 to 80% of the code written by AI already. Another good example is there's a database company called Supabase. They are using a lot of AI coding to build their product as well, but it's so many. There's it's harder to see. It's probably better to see which one is not using AI any, rather than which one is AI at this time.
Okay, okay, that's interesting. That's interesting. Okay, so fast forward to today. What main obstacles do you think the AI coding community have solved so far?
So that's we made so much progress over there. The first I would say is more like how do you use a natural language as an intent to write the code. We usually call it vibe coding. Instead of tell what exactly computer to do, we just tell computer, hey, that's what I wanted to achieve. The computer or the agent will automatically figure out what's going on there. That means all the learning we did in the college for understanding all the programming language schemas is not needed anymore. It's great. We can use our language to talk with the computer. It's nice. The second one is more like, the to be able to write a good software, we used to have to learn how to write different programming models, understanding different frameworks. A lot of people doing that by just copy paste from forums, asking questions like that. That is dead. Nowadays, you don't need to do that anymore. The model will automatically find pretty good at find the right programming model, the right way to leverage different frameworks over there. That's the second thing. And more important, previously, you can only do one shot, right? You ask the AI to do one thing, and then it's trying to answer you immediately, the question answer type of things. But recent years, especially last year, we moved into the multiple turn agentic type style. The AI will start thinking about this, make reasons, and start trying things. If it doesn't work, come back, think about it again, try it again. It's not that perfect yet, but it's solved a lot of problem in depth. The scale-wise, it was like from a line of code into a file. Now it's more like pretty much close to the small repository level things over there, which is makes the ceiling much higher. Those are kind of a major achievement from AI coding side.
Okay. So what main obstacles are still remaining?
So that's a few things. Number one is the very, very classic computer science problem. How do you know your code is right? Right. So when you produce something, does it satisfy your intent, or it does something else you don't even know? Do you have side effects? You ask one thing, it did 5 things for you, right? Those are still not totally solved at all. So that is still one of the big problems today for the AI coding adoption. Companies start writing a lot of code with AI, and when they release, we find so many issues over there. We cannot overcome that problem yet. So that's one big one. Second one is it's more like efficiency optimization, right? So the companies throwing a lot of token because the AI is getting smarter and smarter. It's thinking again and again. We just talked about multiple turn stuff. The token usage is becoming a huge cost. It's a new currency in the coding area, right? So how do we effectively use those tokens? It's just still not solved. That's the third one is more like it's kind of very interesting. To build a software, coding is just partial of the equation. There's a lot of other aspects like how do you fund what it requirement is, right? How do you design your system, code it, and then how do you test the result? How do you make sure nothing is broken? All the entire process, end-to-end, I call end-to-end life cycle of software building is still not solved. We improved the coding side a lot. Other part is still the bottleneck.
Okay. You also talk about high-level abstraction. I think, can you elaborate a little bit more on that? What do you mean by that?
So basically, think about the entire history of computer science, right? We started writing the machine code, binary code, right? You punch the holes with the belt.
Yeah.
There is where the Turing machine comes from. That's where we started over there.
Yeah.
Later on, we invented assembly language. Better, you can type something. Computer directly deal with the hardware, right? So over there. Eventually, we invented a higher level programming language like C, Java, those languages over there. We improved the different level of abstraction, right? So human can deal with the machine. That's how history goes. At this moment, we kind of get into, we may be able to use natural language to manage all this stuff. But there's a big problem between the computer and the natural language is ambiguity, right? So human language is not deterministic. But the computer is. So
Yeah.
there's some translation in between need to be solved. That's what I mean. Maybe some level of abstraction need in between the human language and the kind of current programming language so that machine and human can work together better.
Okay. So in a perfect world, how should AI coding work?
I also give you thinking about this, right? So previously, everything is binary. Now we don't see the binary anymore, right? We only see natural language, high level language code. In the future, we should not see that as well. It should be hidden under the hood, right? That's the future. So ideal world is we just want to do something. Say computer or machine do something for us. That's what I want. And automatically it internally produce a bunch of things. You need to do all the instructions and then do it under the hook. You don't need to worry about how it happened. You only worry about what you want. I think that's the ideal world. So just becoming from code to no code. If we put a no code, but the code is still there, just hidden somewhere.
Okay.
That's the future.
Okay, I look forward to seeing that. So you founded DeepMorph. What are you trying to solve with this latest startup?
Yeah, so I think the one important thing we saw is human cannot match the speed of AI coder anymore. AI coder produces so many code over there. So how we are kind of becoming the bottleneck of the things because we have to guarantee everything is okay, nothing is wrong before we give it to user to use it. So how do we make ourselves kind of in the command mode, right? Ideally, what happens is your keyboard is from 26 keys into 2 keys. You just say yes or no. There's only 2 keys you need over there, right? How to make the human in kind of that condition, in that situation, so that we can prevent all the bad things that happens before we launch stuff to the end user. We use software every day now, which is not a software part. It's harder to define. You just fly to your vacation place, right? You're on the plane. Plane is controlled by computer now. Everything must be cracked. So in this company, we're trying to invent a new mechanism so that we can guarantee nothing bad happen. Use in AI is safe. Human, like as you mentioned already, human need to be in command, but not a bottleneck. That's the company's the target is.
Okay. Can we maybe talk about bottleneck? Like a little bit. I talked one of my previous guests. He called it like an agent orchestration platform.
Mm-hmm.
And the idea is to have, I think he had up to 50 agents running concurrently nonstop for days, right? That's more like on the orchestration front. So what does removing human from the bottleneck mean to you?
So that means you can judge. Human should be in the judge role, right? So you have, like you said, orchestrate a bunch of agents working over there. Great, it's produce something. We don't really know what is the constraint we should satisfy in the system. That is not defined anywhere first. It's hidden all over the place, inside your code, inside your data, all over the place. All the agents start working, there's produce a lot of artifacts over there. So how do we consume that artifacts to match machine speed, right? So that's really the bottleneck today. So Amazon hired a bunch of engineering back to review the code, but that's cannot catch the speed of AI as well, right? So on one side, a lot of people working on to produce more things. On my side, it's like, can we kind of consume whatever AI produced in a way we can just say yes or no. So use our native understanding of the problem, right? For example, the business people cares about, okay, I have 5 business rules here. So you launch something. Did you change that or not? If you change, what are the consequences to my consumers? What are the consequences to my revenue? So that's the security guys cares about, okay, you launched something, I'm regulated domain. Did it break my regulations so that the government will chase me after we launch? So those kind of things need to be answered by the AI and the human together. That's what kind of we're talking about unblocking the things there.
Okay. So last question. We have read headlines, right, saying computer science majors in college, right, they have a hard time finding jobs, and so some people are thinking perhaps people shouldn't get into computer science major anymore. What do you think?
That's a great question. Actually, my son asked me the same question. So I can give you a little bit how I think about this. So I was thinking about what's really the fundamental or the broader definition of the computer science, right? At the very beginning, the computer science is created to see how do we build the computer first, right? And then how do we use the computer to solve the human problems, right? I was visiting London to see what the first computer got built over there. It's amazing. It's just solve a very interesting niche problem over there. Now it's much wider. So the computer science, including the parts like how do we understand the computer's limitations over there first, right? What a computer can do, what a computer cannot do. What is computable? This is one branch over there. How do we effectively interact with computer? How do we teach computer to what we want to do? That's a kind of programming, right? So we invented language, we invented user interfaces with the computer. How do we make computer work together? Right, we invented the internet, we invented networking, everything like that. I mean, there's a lot of examples over there. But this with AI move us into a different position. Some of the things doesn't matter anymore. I think computer science, the education needed to be redefined. The big shift should comes from how do we teach a human to work with computer. That's today's norm. And it should be how to teach a computer how to work with a human. You can see the difference, right? So one is So it's we are kind of follow the computer's move. Now the computer should follow us. That's the big shift that we should kind of consider. From that angle, I think the college education for the computer science is probably going to be transformed and redefined. The problem didn't really reduce. That's the beautiful part of that. So the people passionate about this kind of how to leverage computer solve human problem should stay with computer science. This is from like a science point of view. But from another angle is job market, right? We live in the world, we need to make money. So computer engineers so far is one of the best occupations to make money, right? Of course, you can argue AI engineers are making a lot more money now, so that's fine. That from job marketing point of view, the current job market will shift as well. So if we wanted to take education, go to college, and make sure you kind of understand the need for coding is going away, but the need to solve the problem didn't go. Need to build AI or leverage AI to solve the problem didn't go, right? So computer science is still going to play a big role in this new wave. Just the definition will be shifted over there. So I would encourage young students looking for the future of the pace, trying to understand, is this a problem you want to solve or not? What drives your passion? Rather than, and of course, if your goal is making a lot of money, so that's a different story, right? So, but our goal might not be the same. Different people have different lifestyle or career goal over there. Just make sure you do whatever you think is most impactful. That's my recommendation.
Okay, thank you.